I'm Mahalakshmi Palinji, and today's topic of session is the learning outcomes of the session are we'll learn about different SPICE simulators, an introduction to LTSPICE, the different type of simulation that you can do using LTSPICE, the SPICE directives needed for running the simulation, and we'll see how to download and install LTSPICE with a quick review of the software environment with an example. These are the different SPICE simulators which are available. They are PSpice, LTSpice, NGSpice and HSpice. Now PSpice and LTSpice are basically used for educational purposes, whereas NGSpice and HSpice are used for professional purposes. Now why so? It is due to the difference in the algorithm that are used in the simulators. Now example, if I have a bigger circuit with large number of components in it and I run it, so PSpice and LTSpice will take much more time to give output rather than NGSpice and HSpice. Now why there is a need to use these simulators is a big question. Now, as a circuit designer, in order to understand a circuit, I can use three types of analysis. One is mathematical, by solving. Second will be by using hardware, designing it and finding the output. And third, you can simulate the circuit and find the outputs and analyze the circuit. So using these circuit simulators, you can run any circuits and find their respective outputs as per your design. Let's talk about LTSpice. LTSpice is a SPICE simulator for electronics. It was designed by Linear Technologies, which is now under Analog Devices. The aim of LTSpice was to design and simulate the circuits in integrated circuits in order to make the design of IC simple. The main advantage of LTSpice, it is a freeware software. Let's see what is the need of LTSpice. LDSpice can be used to simulate different analog circuits that you have designed and study the functionality of the circuits and to find the limitations of the circuits if any. So you can run any kind of circuit and study the circuit by using LDSpice. Now these are the different types of simulation that you can run under LTSpice. They are transient simulation, AC analysis and DC sweep. Let's see them one by one. Transient simulation is used for getting outputs which are I want it in terms of current versus time or voltage versus time. They are time-based simulation, whereas AC analysis is used to obtain frequency responses. DC sweep is used to get outputs where I need input versus output or DC transfer characteristics. Now, in order to run these simulations, I will require some SPICE directives. SPICE directives are nothing but statements that start with a dot. Example, dot trans is used for transient analysis, dot AC for AC analysis, dot DC for DC characteristics or transfer characteristics plotting, dot OP for operating point analysis. Dot OP can be used to find out voltages at any nodes of the circuit and current through any branch of the circuit. Now let's see how to download and install LTSpice. Using this link, you can download LTSpice. So let's see how to download LTSpice. In Google, type LTSpice. So when I type LTSpice, I get the first link from analog.com. Go to the Analog Devices website. Go to the Analog Devices website and download it. You'll find here two options to download LTSpice for Windows and Mac. So if I click for Windows, you'll be able to download LTSpice for Windows. Just save it wherever you require. Now I already have it saved in my desktop. So in order to show you, this type of icon of LTSpice will be downloaded. So let's see how LTSpice environment looks. Now, this is LDSpice icon which will be downloaded. This is the file window of LDSpice. Now, in order to start with any new schematics, go to File and click New Schematics. This is a schematic window where you will place all the components and design the circuit. Let's have a quick review of all the symbols shown on this window. You have a save symbol. You can find a man running symbol that is used to run the circuit that is to be simulated. Here you have a magnifying glass which is used to zoom in and zoom out your circuits. You have here cascaded windows and tile windows. Now these are used to organize the windows when you run any circuit. Example, when you run a circuit, you get a simulated waveform window, you get a schematic window. So these windows can be managed by using this. Here the scissor is used to cut any components. In LTSpice you don't have anything like delete. So using this scissor you will delete it. I'll show you an example. Here you can find a resistor, capacitor, inductor, diodes, which are the components. So if I place the resistor and I need to cut the resistor, so I'll use the scissor and cut it. Next, this is a wire in order to join two components. So let's see if I have one resistor and another resistor, how to join it using a wire. So click on wire, place on the component and drag it and place on another component. So two components are joined. Next is here you have ground. Next you have a label net. Suppose I want to label this node. So using this label net, I can label this as example out. So if I'll place it here, this node will be labeled as out. Next, using this AND gate symbol, you can find all the different types of components that are supported by LTSpice. You have voltages, MOSFETs, BJTs, op-amps, so you can use them. Next, using this move symbol, you can move any component, and using this drag, you can do the dragging. You have an undo command too. Using this text symbol, I can place any text that I need to place on my schematics. Example like this. The last one is the SPICE directive. Using this, I can write the SPICE directive statement whichever I require. So in this manner, this was a quick review of all the symbols. Now, if to run any circuit that is drawn by you, go to simulate, and before running, I need to edit simulation command. So here you can find different types of simulation that I spoke about. Transient analysis, AC analysis, DC sweep, DC transfer characteristics, and DC operational point characteristics. So now, let me show you one example. Now suppose if I click a resistor and place it here, when I remove the cursor, I get one more resistor. In order to get rid of that, just right click it. So you'll get rid of that. I hope the connections and the symbols, how to do connections and the review of symbols is understood by you. So let's see one example. Now, suppose I take a new file, that is new schematics. Let's run and see a voltage divider circuit. I hope you know what is a voltage divider circuit. Voltage divider is nothing but, example, a 2 resistor circuit connected in series. I require a voltage source. So using this component, I'll select a voltage source. Yes. Now, using ground, I ground the voltage and the resistor. So all my components are done. Using the wire, now just do your connections. I'm connecting the circuit. So in this manner, I connect all the circuits. Now let's put the values of the resistors. Now clicking this R, right click R, and suppose if I give the value of the resistor of R1 as 5K and R2 as 10K. Let the voltage, DC voltage, be 5 volts. Now in order to find voltage divider, I need to find voltage. I take output in between the resistors. So voltage divider output, suppose I label this and place an output port. You can select your port. Let me name it as output. So I will place it here. So this is my output port where I can find the output. Now let's run the circuit. Now when I go to run the circuit, I'll get the edit simulation command window. In this case, let me take a transient time. Let the circuit run, for example, 1 millisecond. I'll just try with 1 millisecond. Now when I run the circuit, see, these are the different windows which were open. Okay, so these are the two windows that we were talking about. This is my circuit that is simulated, and here by this side you can find the waveform. That is 0 that runs from 0 to 1 millisecond. Now in order to trace the circuit, right click here and click on add trace. You can find here all the node voltages and the current through the branches. Now let's find what is the node voltage that is at output. It is nearing to 3.33. Let's find the exact voltage. So to find the exact voltage, right click on the title of V output. You will get to attach a cursor. Select the cursor and place it. Now here you will find the values that shows the coordinates of this point. So this shows the value is 3.333. So voltage at node output will be 3.333. You can verify it using a voltage divider theorem. What does voltage divider theorem say? The output at this node will be R2 upon R1 plus R2 into the DC voltage. So 10K upon 10K plus 5K into 5. Just calculate and you'll find the output voltage at this node will be 3.333. Now you can find out the voltage at this node also. Now after running, when I go to this window, you can see a probe and the cursor is like a probe. So when I place here and click it, you will find on the window you get one more waveform, that is of V of node 0, 1. That means this node is 0, 1. Now suppose if I have not labeled this output. Yes. So now let me run the circuit. Okay. I can cancel. Now I'll show you how to cancel or delete the waveform. Now just right click on this and delete the trace. You can delete any traces you want. So now run the circuit. After running, now if I place my cursor over here, it will find this node voltage. And if I place the cursor over here, it will find this node voltage. So this is node 1 and this is node 2. You can see node 2 is 3.333 and node 1 is 5 volts. Now since the axis is exactly the 5 volts, now I can change the axis also, visibility. So keeping your cursor on the axis, right click and you can click and change the axis values. So suppose I want the axis from 0 to 10 volts. So now you can find node 1 is the black waveform, that is it shows it's 5 volt and node 2 is 3.333. Now if we use label net, I can label any nodes that I want. So that is one of the advantage where you can get directly. Now if I label this as point A, the node A, example, and I label this node as B. So now if I run the circuit and try to trace it, see, I'll get here node A and node B instead of node 001 and 002. So you can directly find the voltages if you label the nodes. I can even find current through the resistor. This is the current through the resistor. Now one more example I would like to show you. When you right click here, you can see add plot plane. If I add plot plane, two windows will get open, two panes will get open for plotting the waveforms. So right click on this plane and you can trace out any other voltage or currents. So in this manner, you can find different voltages in one single plane. Now in order to delete this plane, again right click and you can Right, click on here and you can delete the trace. And if I want to delete the plane, you can delete this plane also. Now one more feature is by clicking to add trace, I can find power. Now how to find power? Example, like I can multiply a voltage. Using expressions, I can multiply the voltage into current and you will get the power. Now see, since it's power, the axis has come with a watt unit. So this is a power. So using this expression feature, I can find any expression that I want. Suppose I want node A minus node B. So you will find here node A minus node B. What is the voltage? Let us find that. Yes. See, the voltage is 1.66. So node A was 5 volts and this was 3.33. So difference is 1.6. You can use any expression. Now here you can see there are three axes. One is for power, one is for voltage and one is for current. Since I have plotted all the three at one pane. I have plotted all the three in one single window. So I have got three axes. I hope this example is clear to everyone and you had a quick review of how to run any circuit using Circuit Simulator LTSPICE. I hope you try different circuits and let me know in comment box that how did you find LTSPICE to run the circuits. I hope with this example everyone got a clear idea how to run any circuit using LTSPICE. So in this manner, we have simulated voltage divider circuit and seen the outputs. I hope this session was informative to you. Thank you and stay tuned for further lectures on LTSPICE.